I guess in the last video I should have ended with these two problems, but because these are just review problems of what we ended with, you might want to try these. So if you want to, you can pause. So when I multiply 3i times 5i, I'm just going to get 15i squared. Just multiply the parts there. And remember, I squared equals -1. So this is 15 times -1, which is just -15. So remember, anytime you see an I squared, substitute a -1 in place for that. On this next one, we have the square root of -2 times the square root of -6. Again, I would start by bringing the I out. Remember the square root of -1. Anytime you have a negative underneath the square root sign, that's going to be I root 2 times I root 6. And now remember, we can simplify first if you want to, since it's just multiply. This is 3 times 2. I have a 2 here and a 2 here, and I could share that factor. So I have 2i squared times the square root of 3. And I squared equals -1. So we get -2 times the square root of 3. That would be my answer in simplest form. Okay, I to the 35th power. Now, in order to do this, we're going to kind of investigate a little pattern. So if I have I to the first power, that's just I to the second power, remember, and this was the square root of -1, but we just think of it as I to the second power, remember, anytime we had an I squared, we get -1. I to the third power, we're going to have we can think of this as I squared times I. Remember, you would add the exponent, so I squared times I would be I to the third power. So I get -1 times I, which would be -I. I to the fourth power, I can think of as I squared times I squared, which is -1 times -1, which is 1. Now, if I went on and did I to the fifth power, I would have I to the fourth power times I, which would be 1 times I, because remember, I to the fourth power we just said was 1. So I get I. Now notice that's where we started. So I had I was our first answer here. Then I, and then we had a -1, and then we had a -I, and then we had a 1, and then we had an I again. Now the next one would be a -1. So I have this repeating pattern. Let me go back to the pen here. So I have this repeating pattern of I, -1, -I, 1. I, and then it would go back to -1, -I, 1. So every fourth power is going to come back to where we started. It's going to just keep going in a cycle. So if I wanted to know what I to the 35th was, I'd need to know how many times did I go through this. And I could count 1, 2, 3, 4, go back to the top, 5, 6, 7, 8, 9, 10, 11, 12, but that could get really old. So instead what I can do is I just need to know how many 4s are in 35. So 4 goes into 35 8 times, and there's 3 left over. So that's going to mean I'm going to go through that pattern of four different answers. I'm going to go through that pattern 8 times, and then I'm going to go, then I want to see what am I going to have left after I go 8 times. 1, 2, 3 is what I had left. So my answer, I to the 35th power, equals -I. So this is the pattern you'd need to remember. I, -1, -I, 1. And it's just going to keep repeating that way. So I to the 37th power, 4, really you don't care how many times it goes into it, you care what the remainder is. So 4 goes into 37 6 times with a remainder of 1. So remainder of 1, you're going to count just to the first place. So I to the 37th power is just equal to I. If you wanted to know I to the 513th power, you would take 4 into 513, divide this out. 4 goes into 33 8 times with a remainder of 1, because all we care about is the remainder of 1, which means I'd be at my answer, remainder 1, would be at this first one. So I would have I. If I have a remainder of 2, it'd be negative 1. A remainder of 3 would be negative I. And a remainder of 0 would be 1. Okay, for this problem, I'm just going to solve the equation. So think about what you do. We got to get y squared by itself. So I'm going to start by subtracting 20 on each side. And I get 5y squared equals negative 20. Next, I would divide each side by 5. We get y squared equals negative 4. Now, the next thing would be to square root both sides. Now, when I square root both sides, and I think we had seen this once before, but if I have the y squared equals 25, then y equals 5, because 5 squared is 25. But also y could be negative 5, because negative 5 squared is also 25. So I can show that since I get either a 5 or a negative 5, I can put those answers together and say plus or minus 5. So over here, I'm going to take the square root of negative 4. However, it's plus or minus for the same reason that this was plus or minus. It might be a positive root, it might be a negative root, or a negative answer, square root. So I have a negative, so I have to bring the I out. It goes after the plus or minus sign. And this, let me leave room here. And the square root of 4 is 2. So I just get 2i. It might be positive 2i, or it might be negative 2i. And you could write it that way, 2i or negative 2i. But the plus or minus sign is just a shortcut. So you solve the equation just like regular. When you square root, to undo squaring, we square root. So it's plus or minus, but remember it might be, but then this negative is, because it's a negative underneath the square root, we have an I. Square root of 4 is 2. So we get plus or minus 2i. Here's a problem that might look kind of complicated, but it's really not. Find the values of x and y that make this equation true. And really all you have to do is match up the real number part to the imaginary part. Remember I'd said a plus bi is the general form? Well, this would be the part without the I is the real number part, and the part with the I is the imaginary part. So when you do this, you'll match the 2x matches to the negative 14. So I have the equation 2x equals negative 14. I just match up the real number parts. And then I have the imaginary part, yi, has to equal this imaginary part, which is negative 3i. So I get yi. Actually, I can just match up. I don't even have to use the i's because they're going to have I on both sides. I can just say y equals negative 3. On this side, I would divide each side by 2. And I get x equals negative 7. There's nothing to solve here. Y equals negative 3. And that's all there is to it, because it said find the values of x and y that make the equation true. So 2x would have to equal negative 14, or x is negative 7. And this y would have to be equal to negative 3. So here's one you could try. The 3x has to match to the 15, which means x equals 5. The negative y matches to the 2. which means multiply each side by -1, y equals -2. And this section is going to have 3 videos because we still have quite a few examples we have to look at.